a person who is coming now has a strong background in computer vision and deep learning. Throughout his career, he has worked on various projects, including developing iOS applications, working on text classification using neural networks, and working with image data processing. He is in the position of a machine learning engineer and data processing consultant. Please welcome Miroslav Jaščur from VISMA.
Thank you very much. Ladies and gentlemen, I will be talking today about document AI at scale. I am from VISMA Machine Learning, and let's get to it. So first, I will introduce our team. I will talk about our products, which are SmartScan, AutoSuggest, and document question answering, which is the latest iteration. It is a generative model. I will iterate on technologies that we use, and I will talk about the inference server that we use, which is Triton Inference Server, and how do we leverage the power of this tool to our benefit to reduce cost and latency in inferencing with our neural networks. Let me introduce our team. So we have Klaus Dahl, which is our team manager, Lilia, which is our product manager. Then we are split into data scientists and data engineers. So the data scientists are from Denmark, mostly. That's Lasse, Esben, and Christopher. And I forgot to add Benjamin and Hadi, which are the newest additions. And then we have data engineers, which is just Slovaks, which is kind of funny that we are split that way, but it is what it is. So that's Anton, Michael, Lucas, and Miroslav. And I forgot to add Martin. And we have 3 QA assistants, which are a really important part of our team, since they do all of the labeling, so all of the manual and hard work. It's not that easy to be a good QA assistant.
We all spend a lot of time digging through information, but finding what you need can be hard. With VISMA SmartScan and AutoSuggest, you get the info you need and spend less time doing manual work. Take this example from accounting. Simply use your smartphone to scan paper invoices. The software uses machine learning to extract the information you need and gives you suggestions for how to put this data into your accounting system, which you can apply with a simple click. Find out how you can spend less time doing manual work.
Okay, so I didn't thought it would play immediately, but basically it was supposed to introduce our domain, which is accounting, and for us it is mostly processing of receipts, invoices, and any other text that is tied to accounting. It doesn't have to be tied directly to accounting, but this is our main purpose, my main goal of what we do. So we have 3 products again. We have our crown jewel, which is called SmartScan, and this one extracts structured data from invoices. What that means is that you take an invoice or a receipt with any text, and you output a key value dictionary. So you get text in, JSON out. That's it. And how we do it? We do it with rather large transformer with 250 million parameters model. The core is based on BERT, and we also add some layout information into the neural network. So this product is simply static API for invoice and receipt classification. That's it. Then we come to AutoSuggest, which is slightly more complicated from engineering perspective. And it receives data from our customers. It receives text, or you can imagine it as invoices, and we do custom classification on their data. And we use neural networks that have around 100,000 parameters, depending on how many inputs are there. And those are just fully connected networks with custom text encoders. And then we have our latest edition, which is document question entering. That's ChatGPT-like model. So it has 1 billion parameters. So this one is getting closer to the latest big models. Not really 1 trillion, but 1 billion. That's, I think, between ChatGPT-2 and ChatGPT-3, somewhere there. And it extracts text-based prompts based on prompts from user. So our user can ask a question, and you will get it answered in a way that the user is able to define its API. Because if you form a question and if you send 1,000 documents with the same question that you formed, you have, in a sense, a dynamic API. It's still in beta because of all of the issues that ChatGPT and generative model have. Okay, so let's get into the details of our products. This is the Smart Scan, our crown jewel. So usually the customer sends us an invoice or receipt. It's either PDF or an image. We transform the PDFs into images, because those are easier for process from Google OCR, and we extract the text. With text extracted, we proceed to next step, and that is tokenization and all of the pre-processing stuff that are needed for neural network. And then what we do is called sequence labeling or named entity extraction or token classification, however you want to call it. So your transformer will tell you where some static fields or some key values are in the text. So it will, for example, it will tag order date in blue. It will find total VAT. It will find total excluding VAT in the text. So it's basically a intelligent text search. That's Smart Scan. We are used. Okay, you probably cannot see that, but that's Europe. We are used all over Europe, and we have we will probably have our first customer from America, from Argentina, which is kind of interesting. But yeah, so we have suppliers from more than 25 countries, and we support multiple languages. At what scale and speed are we operating on? So we support 21 static fields. We have 280,000 daily scans at peak throughout the day. That's somewhere around 10, 11. So right now, we process around 10 to 15 documents per second. We do more than 8.9 million documents per month, and we do much more than 80 million documents per year right now. And we do all of that with median latency below 1 second. So we do that synchronously, which is really, really interesting. And it is taking into account that we are doing that with OCR and transformation of PDF to images. So in a way, it could be either 3-step process or 2-step process, and it all happens under 1 second with state-of-the-art performance. And why is that difficult? It's difficult because there are so many layouts of recipes and invoices. There are no standards for invoices or for receipts or for bank transfer statements. So you can get anything, really. Language, that phrasing is inconsistent. You can say the same thing in 5 different ways. You have to support multiple languages, which makes this much more complicated because you have to train on different languages. You have to pre-train on different languages and all of the small stuff that we don't really notice. And a lot of our data is unlabeled. So it usually, sometimes it say that this is the total what, but sometimes it just say percentage and value. And at that point, you don't have labeled data, so you have to find it. So this is what it makes complicated. And again, we solve it with BERT and with transformers. And we input some layout information into our model. will not go into the model details because this would take much longer, but let's get to our another product. The second product that we have is AutoSuggest. Again, vastly different. It is custom text classification. So usually, user sends us an API request. Here I have some blue invoices. Here I have some green invoices. They are not green, but they were green on my screen. And he asked us, OK, so train me the model on this data. So what we do is schedule a training. We train a model. And we have some model artifact. Model artifact is just a file with some weights or with the configuration of a model stored. And we load that model into our inference server. And at that point, we are able to receive requests from our customer. So our customer sends us brand new invoice. And he asks us, tell me the color of this new shiny invoice. And we respond, it's probably green because we know how to train the model on this very simple task. Now, where it gets complicated is that repeat this process 100,000 times on 100,000 different tasks. So from engineering point of view, this is much more complex problem than the one before that. And what scale are we operating on? So we have 433,000 unique datasets. We ingest 6.1 million invoices and receipts per month. We do 530,000 daily inferences, and we do 16.6 million monthly inferences. And we do all of that below 500 milliseconds on average. And our latest model, which is document question answering, so ChatGPT-like model. And you have a short conversation there with the model. So it doesn't have, I'm not going to go into that, but yeah. So how much is deposit due? So you're going to prompt the model, you're going to send the image and text to the model because it's a multimodal model. And it will answer you nicely. The deposit due, I did find it here, and it's 169.95. So it did understood the question, and it answered it well. But also, you can ask our model, what will be the weather like tomorrow? And also send the invoice and be like, and it will answer you most of the past, so it will hallucinate the answer. So this is why it's still in beta. This is why we still need to do a lot of validation to get to the point where this will be production ready. So that's where the current struggle is. How do we do it? So now I'm going to just list a few technologies that we use, and then we'll go into the detail of one of the technologies. So we are on Kubernetes with GCP. We use Golang microservices wherever it is possible. If it's not possible, then we go to Python. We use a Spanner, BigQuery, and Firestore for storage, and Istio for observability and traffic management. And then we are kind of vendor locked in from that point on, because we use GPU infrastructure. And we use two types of GPUs. We use the cheap ones, which are T-Force and L-Force. Those are the cheap GPUs. And then we have pricey GPUs, which are V100s, A100s, and A100s. They progress in price within that order. And also, we leverage some software from NVIDIA, which is called Triton Inference Server, which is my goal is to explain why is Triton Inference Server very good. But let's get to what is Triton Inference Server. Simply put, it's a piece of software that is able to call the trained model and return the output data. So it accepts some data that are passed through API, that are parsed and sent to the model. Then they are parsed out, and user gets a response from the API. So it's a very simple idea, but it gets complicated very fast when you have different models different frameworks, but the idea is very simple. Inference server calls the train the model. There are some standardization of efforts in regard to inferencing of the neural networks, and that is ONCs, which is a standard for output format of the neural network. So it's, I think, Open Neural Network Exchange format or something like that. That's the shortcut. And for standardization efforts are also ongoing in inference servers and other ML infrastructure. And the product is called Kserv, which is a layer of abstraction in Kubernetes. Not only abstraction, but yeah. So to get back on track, again, we have our 3 products, and they have a very vastly different requirements for inferencing. First one, SmartScan, big model, 250 million parameters, and at worst, it has to run below 2 seconds with OCR and PDF transform to keep it synchronous. That's the main goal. Autosuggest, a lot of small models, thousands, hundreds of thousands of small models. We have to load and infer and unload them on demand because we cannot load 100,000 models into RAM at the same time. And we want to be way below 1 second, and this requires a large parallelization of all of the processes. And the third one is the 1 billion model, and that's document question answering. So it has the same issues as the SmartScan, but also you have to run the generative part. So the one that generates answers. So you have to run that multiple times. And good answer, like how can I do that, is just use Triton Inference Server. And again, it's a software for inferencing models. It takes a model artifact and creates a service around it. You upload your model artifact, you do some configuration, you launch the container, and you are ready to go. You can make gRPC or HTTP calls that adhere to the configuration that you set up. What is amazing about it, it has multiple backends. It has TensorRT, it has TensorFlow, it supports TensorFlow, PyTorch, ONCs, whatever you want. And from machine, that's from deep learning, so neural networks, and from machine learning, it supports XGBoost, scikit-learn. So if you set it up properly, you are good to go and deploy anything on it that you want. So this is the architectural overview of the Triton inference model, and we are getting very technical right now. But we can see, so we have some API that we can call through either HTTP or gRPC. The inference request is passed to model scheduler queues. So those are queues that are waiting until the model is available. If the model is available, then it runs the inference on one of the selected backends that you found. And it is also, if you use the correct format of the model, it is hardware independent. So you can either run it on GPUs or CPUs. So you do the inference, you return the model, and it's done. You load the model artifact from persistent storage. And another great thing about it is that you have status and health metrics that offers you a lot of observability, which is a really valuable thing when you are doing stuff and in mass. You can observe the latency, you can observe how fast the models are loading, and other details. Okay, this one is, those are the 2 toughest slides. So those are Triton features. I'm just gonna fastly iterate on them. So those are the things that Triton is able to do. The dynamic batching means that the neural network, it is more efficient for a transformer or for a neural network to wait some time and process multiple requests at the same time. So this is what is called dynamic batching. It is a waiting time or wait time until the next request comes. So I can run it once at GPU and then respond with 2 requests. Sequence batching, it is something that we are able to keep an internal state for recurrent models or for models that have some state to keep. Then we get into concurrent model execution, which is just model replication. So you copy the model multiple times into operating memory of the GPU or CPU, and you are able to concurrently call the multiple models. So that's where a lot of concurrency in smaller models comes from. Next features. So model ensembling, which is that you can pipeline all of the pre-processing and post-processing into a single pipeline. So you get rid of all of your Python code with Triton, and you don't have to care about other pre-processing and post-processing outside of the Triton environment. We can also optimize model. So the usual way to optimize the model is quantization. So with TensorRT, we can go to floating point 16 or to TensorFlow 32, or we can use mixed precision models, which are supported in TensorFlow. Then we have Triton model analyzer, and we have model management extension, and model warm-up, and a lot of observability. So all in all, it is really featureful. That's what I wanted to say. It's a really, if you want something out of your inference server, Triton probably has it. So how we leverage Triton? For the first time that we used it in SmartScan. So originally, we were using different inference server called TF serving. But when we received a new model, it was simply too big to run, too slow to run. So on V100 GPUs, which are not the cheapest GPUs, they are kind of pricey, it ran within 700 milliseconds on GPU. So it was in TensorFlow in full precision. So we had option then to switch to even pricier GPUs to A100s or be slow, thus risk our synchronous API. So the question was, would we be able to stay synchronous? But we looked up on we took up on Triton Inference Server, and it was able to serve in mixed precision. So it was able to do some optimization. We were able to stay on V100s, which are cheaper than A100s, and we were doing on average 300 milliseconds. We were processing the request in 300 milliseconds on average. So Triton was drag and drop replacement for our solution that improved latency, cost, and observability. Amazing, all good stuff. Then this happened, I think, 3 weeks ago. And what's new in the world of transformers was flash attention. So it was basically an optimization algorithm that improved speeds significantly. But the only framework that it was implemented on was PyTorch. So we needed to switch to PyTorch fast, and PyTorch is not natively supported. TorchScript is, but PyTorch isn't. So we had another challenge ahead of us. So we decided to use flash attention to create a custom backend with PyTorch. You can see the time gains expected from the flash attention. And we switched from V100s to L4s. So we switched from the pricey ones to really cheap ones. They cost $600 per month. But again, we improved by 40%. So we moved from 300 milliseconds on average to 182 milliseconds on average. So you can see those are V100s. This is the observability that I was talking about. And this is a result of the deployment. You can see that average time really did go down. And we were paying $1,200 per month per GPU for V100. Now we are paying $600 per month. So we improved our latency and reduced our cost again by half. So this is the next iteration of SmartScan, the latest iteration. So that's about it for SmartScan. And now let's get to AutoSuggest. What we were using before, we are still using it in production, but we kind of wrote a first proof of concept. We were using TF serving that was compiled for Golang, which is really hard to maintain. But thanks to the model extension from Triton, we were able to load, infer, and unload models for AutoSuggest, which is what we needed. And the first results are really amazing. So we improved the latency from 500 milliseconds to 150 milliseconds on average. The load times are slightly slower, so that's a bad thing. And we deleted 6,600 lines of code and replaced them with 717. Again, getting rid of the custom code and improving by a lot. We still need to manage the routing of our Triton replicas. That's a networking issue. And in QA, we use the same thing as in the latest iteration of SmartScan. It is a much bigger model then. We are running it on very cheap GPU, and we are keeping inference time below 2 seconds with 1 billion parameter model. And we observe almost no overhead from our inference server. Again, good things. To summarize, Triton. So it is robust, reliable, and fast. It is versatile. You can use any framework that you want. Great tool for optimization, so you can quantize and run in TensorRT. It's simple to run. It's basically a 3-step process that I outlined. It is maintained by NVIDIA, so that's probably good. And it's extensible. So we can customize. You can create your own Python environment and use, for example, Torch Compile, which is a great tool for optimization lately. What is bad about it? That you have to follow annoying directory structure. Load times and model caching are kind of big, and the whole image is bulky. So it's around 5 gigabytes by default, and with custom backends, custom Python backends, it can get to 7, 10, 15 gigabytes. Whatever you install in your Python, you'll get that. And generally, what you should take out from this presentation, that if you are in doubt about how you should deploy your machine learning models, or your deep neural networks, or just your networks, or just the decision tree, use Triton. It is a good scalable solution. Thanks for your attention.
Thank you very much. That was Miroslav Jaščur from VISMA. And as I've seen, right, I think that we've got some questions in Slido. So which of the 3 projects you mentioned is the most challenging from your perspective?
From data science perspective, the most challenging is SmartScan. Because we have to maintain state-of-the-art accuracy, and we have to keep doing that. So we have to iterate on a model a lot. But from an engineering perspective, the AutoSuggest is more complicated because it requires us to do more things autonomously.
Mm-hmm. Okay. And one interesting question about the education. How important is to incorporate AI into educational curricula from your point of view? Maybe
Yeah.
what is your idea about that?
Yeah, I think it's very important. It depends on... it gets complicated within the latest generative models because they are creeping into a lot of aspects of our life. So, but they should be there. The amount that should be there should be decided by the type of the education and the goal of the education.
Yeah, but in these days, in this period of days, we have to use it, right? Also at schools.
Yeah, so basically,
it's very important.
Like, will you develop it at a certain point, or will you just use it at a certain point? Those are like 2 different trees that diverge, and you'll either have to understand them deeply or shallowly.
One more question from my side. How do you have like a feedback from your clients that all of these processes you did help them somehow? Can you see the difference of their behavior towards you?
Yeah, for sure.
Yeah?
They are paying for us.
Okay, and maybe if you can name like the top benefits for the clients.
So imagine, so we have a lot of tax return clients. So basically, we don't have our clients are not directly people who scan the invoices. Our people are software companies that provides tax return software.
Okay.
So, and a lot of the work of their customers is that they have to scan the invoice that somebody paid at some point, and they have to inject all of the data, so it is taxable. And what they do with our software is they pull out their phone, they just snap the invoice or receipt, and it detects all of the data that they need and put them into the software. Or they upload the PDF. And that saves enormous amounts of time for the accountants.
You, with VISMA, you've got a stand here also within Marketplace. Can you maybe tell us something about that, what we can see there? If you don't know, that's okay. We're going to go there.
Go there. We'll talk, I guess.
Okay. And are you going to stay here with us also during the rest of the presentations?
Yes, I think so.
Okay. That was Miroslav Jaščur from VISMA. Thank you very much.
Thank you.